Many of the plants and animals that now live there are found nowhere else on Earth. It was these unique island species that helped to inspire Charles Darwin's work on evolution 160 years ago. And they've intrigued generations of scientists since, in their quest to understand and ultimately ensure the survival of these species. Like all animals found on isolated oceanic island groups, the species found here are astonishingly unafraid of people, or man-made environments. Even on a hotel patio, marine iguanas, a Galapagos species, feel at ease, lounging in the shade of the chairs. With few natural predators, they don't see humans as a threat, making them easy to observe and study. Martin's work is on the marine iguana. He's going to Santa Fe because it's home to more than 1/10 of the world's population of these animals. And here, they're undisturbed by humans. If you study the animals here, you're as close to understanding them as you can get. There's actually an easier way onto the island, but it's 4 kilometers away, and that would involve the team in a long trek carrying all the equipment to the research site. So they choose the direct route. This is the front line of research. What we read in textbooks is knowledge won from situations like this. Most of the islands in the Galapagos archipelago are uninhabited. In fact, you need permission to land on them. Everywhere the human species goes, it affects the environment. This is one of the few remaining places on Earth where human influence and access is tightly controlled. It took Martin months to secure permission to work on the island. More people have been at Mount Everest than have been allowed to come here. This will be the group's laboratory, eating and sleeping quarters. Everything needed for the 3-month stay on the island has to be brought with them. And it's a condition of their permission that everything is taken away when they leave. Now, down to business. First, catch your animal. Although the iguanas aren't afraid, they are slightly wary, trying to stay beyond arm's length. After what's about to happen, it might become more wary. Then the basic data. Body temperature, obtained by putting a thermometer into the cloacal pouch, which all reptiles, male and females, have.
It's 30.0.
For a cold-blooded animal, the temperature seems strangely high, close to the blood heat of a mammal. But as we'll see later, there's an important reason for this. Next, length and weight. These may be basic pieces of information, but they're crucial in understanding how this creature lives.
Okay, 3.55.
3.55. 2 kilos y 100.
For the next 3 months, this iguana is one of many that are going to be intensively scrutinised. So to identify them, each is given a distinctive mark and number. The range of species found here, and here alone, makes these islands an endless source of fascination. Santa Cruz, the main inhabited island in the archipelago and home to most of the scientific work. At the Charles Darwin Research Station, a study is underway which relies as much on the geographical position of the Galapagos, on the equator, as the species itself, the giant tortoise. Beatrix Schramm collects environmental information. First thing every morning, she measures temperature, humidity, and light intensity. She's interested in the mating behaviour of the tortoises, and is trying to discover what triggers it. As the Galapagos are on the equator, the length of day doesn't change all year round. So what is triggering the mating behaviour? Beatrix is looking for measurable signs of sexual activity. Her starting point is sex hormones, which can be found in the animal's urine. Collecting urine samples from a 70-kilogram tortoise isn't easy, so she gets them from the next best thing, fresh feces.
Yeah, this fecal samples, I'm not sure from where, and this other one there too, I'm not sure from whom it is, because as you see, this tortoise is just running away now, and because they are so fast, it could also be from another one. I mean, in this morning, I don't know who else stayed here. So this will be a little bit elder because it's not so humid anymore. This perhaps, yeah, a little bit elder, like 1 hour or something like that. You can check this. If there is lots of humidity, they just made it. And that's why I have to run. If I see a tortoise and she's sitting somewhere and she also saw me, they start running. So I have to run too, to look at which direction, from which direction she was coming. And when I just saw, yeah, she's running exactly away from this fecal sample, which I could see now, and she's just like half a meter away. I know this is from her. But the best way is always that you can see the animal sitting exactly on the top of the fecal sample, that you can see where the tail is, there is some feces, and you can collect it. That's the best.
The tortoises produce the feces first thing in the morning, and Beatrix needs it fresh. They know she's around, so it's a bit of a game of hide and seek. Even when the animals are secure in a rock-walled compound, finding them can be tricky.
Beneath the bushes.
Tortoises can be extremely quick and are very shy. To use a sample of the feces in her research, Beatrix has to be absolutely sure it's come from the tortoise she's spotted.
Let's see, there is one. There is one.
And the sample really must be fresh. Any delay and the hormones in the feces are degraded very quickly in the heat.
I know exactly where she's sitting. So if she's running away when we're coming, I know that this is the feces of her. And now, it's a very fresh one. I have to collect that.
Success. The next job is to stabilise the sample before any changes take place. In a nearby lab, she teases out 4 grams of the material and suspends it in alcohol. The sample is now ready for analysis. Although the station has sophisticated facilities compared to Martin Wikelski's iguana research setup on Santa Fe, it's still over 1,000 kilometres from the nearest equipment capable of analysing the extremely low concentrations of testosterone and estrogen found in faecal samples. So the samples are chilled and stored for later analysis. For most of the year, Santa Fe is parched, desert-like. 3 months can seem a long time in this sort of environment. The marine iguana is something of a curiosity. It's the only iguana in the world that lives by and in the sea, and it's only found on the Galapagos archipelago. Iguanas probably arrived on these remote islands on rafts of vegetation and then adapted to the local conditions. Some, like the land iguana on Santa Fe, adapted to eating cactus pads. While the marine iguana has adapted to eating seaweeds growing on the rocks close to the shore. But foraging for this food has caused them a number of problems. As they are cold-blooded and the sea is cold, they must warm up in the sun before going down to feed, which explains the relatively high body temperature Martin measured. The males occasionally indulge in territorial skirmishing, while some have ticks picked off them by ground finch. The cooling effect of the sea is apparent in the effort they have to make to get back onto the land. After a long excursion, holding onto the rough lava rocks and climbing to safety is visibly draining. But how draining? What is the measurable impact on the animal? With a simple strain gauge, the animal's pulled off the rock. Correlating this measurement against its weight and body temperature at the time of the experiment gives an index of stamina.
That's 5 kilos exactly.
But there is a problem with this experiment. If all the iguanas he can catch are hot from basking in the sun, how can he measure one as if it's just come out of the sea? The answer is to improvise. A nearby tidal pool is a convenient place to cool the iguana down, but you have to shift the residence for a while. Another index is speed.
Okay? Yeah.
They take significantly longer to run the course when they're colder. It's as good an index of performance as you need. And what's more, the experiment is conducted so close to where the animals live that the disruption to their lives, always a problem in experiments with animals, is minimized.
I will put it here if you can help us there. Okay.
Meanwhile, on Santa Cruz, Beatrix and her team are hard at work.
Yeah, but it's walking. Lift, 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 lift. On the side. Just very fast, if it's possible. Yeah. Yeah, now está bien.
Beatrix needs a check on whether the hormones collected from the feces are a reliable indicator of sexual activity. So she periodically takes a blood sample from her tortoises. This week, it's the turn of a large male called Chico. It isn't always easy.
Sometimes we have to change the arm because it's the same with us. Some veins are good on one side, some are very bad. Está cerca. Porque hay sangre aquí. So we try the other side.
The discomfort suffered by Chico is essential in helping scientists ensure the survival of this rare species.
So you can see here this part and these lines going from there till this tendon. Here is the tendon from the muscle, and we are following this line going in this small hole. Here's the vena brachialis going up there, and so we try to find this vein. You can't just feel it, so you have to following these lines. That's the best. But nevertheless, sometimes it's difficult to find it, sometimes not at all. I got it, you see? When you got it, it's just a few seconds and then you have it. Muchas gracias, Chico. Sí, por favor. Yeah. Now we have to be very fast. This is a heparin tube. Thank you very much. So this is a heparin tube, and afterwards I will centrifuge it. I will centrifuge it for about 5 to 10 minutes. We only need the blood plasma inside, so we will throw the blood cells away. And in the blood plasma there are the sexual hormones, and these we need.
At very low spring tides, when rocks which are normally covered by sea are exposed, the iguanas graze on the red algae. You have to keep a watchful eye on the waves. The samples are analysed to identify the species. Each has a particular energy content, and the growth rate of each is known. Knowing what's in the animal's stomach, what and how much it's eaten, helps give a picture of the energy balance. To an expert, the chewed fragments from the stomach are identifiable. The purple coloration comes from the seaweed itself. For a complete picture, fresh feces are collected from the rocks, dried, and analysed for energy content. Altogether, the researchers have a snapshot of the energy balance of the animal over a day. What it eats, how much it eats, what it loses, and as a result, how much energy it has extracted from its food. Beatrix has another subject, this time a female.
And now, cuidado. Yeah. Por favor, Camilo, ¿me puedes ir a la izquierda? No, de ahora le sacamos, ¿no? Solamente unos metros. Ahora lentamente. Acostado, ya. Poco más en mí. Ya, gracias. Ya.
But it's not blood she's after.
Okay.
It's ultrasound, the same technique used to look at human babies in mothers' wombs.
Och mira cómo son grandes.
The state of development of the early stages of the tortoise's eggs, the follicles, is a clear indication of where the animals are in their annual sexual cycle.
Now you can see here it's ending. You don't see this side so good, but nevertheless, I mean, you can imagine this is the follicle, growing follicle. Yeah.
As they approach the time of readiness to mate, the follicles show up as healthy and viable. If they're not fertilized, they may be reabsorbed. Beatrix can see the differences between them. The ones that are breaking down, known as atritic follicles, have characteristic hollow-looking features.
Sometimes you can see, normally you can see a very black hole inside here, so you just see some different colors like blackish, grayish, and it's not, normal follicle is totally white. Atritic follicle has some different colors inside.
The Galapagos can seem like a last frontier. The difficult and sometimes primitive conditions in the islands can suggest a lack of sophistication in scientific research. But by using devices like the ultrasound recorder, important information is gained from a painless procedure. For Martin and his group, their efforts lie in turning their shelter into a laboratory where they can undertake the precise and meticulously detailed work of inserting radio transmitters under the skin of selected iguanas. The transmitters are essential. If your only means of keeping track of the iguana is by looking at them, you won't know what they're up to when they're out of sight. What's more, if you're trying to correlate the animal's activities with the information on food intake and body temperature, you need some quantitative measurement, some data. You need a monitoring device that travels with, or in this case in, the animal as it goes about its daily life. Once in place, the transmitter sends back signals to the researchers as a series of bleeps. These are counted off against the clock. After a few calculations, the researchers have a measure of the animal's body temperature throughout the day. They can start to piece together a little of its life.
You see here a file of time against body temperature, and you see immediately that with the telemetry we get some nice data sets on certain aspects, on certain time periods. But you see, just between say about 20 hours and in the morning at 6 hours, we can't continuously record the body temperature, and we just have to assume that there is a continuous line, a dropping body temperature. We have some nice information here on the time when the animal was foraging, and that's also some nice aspect of the telemetry, that we get immediately the data on the body temperature, and we can design experiments to change certain aspects of the body temperature.
As the graph shows, there are gaps. The technique isn't perfect. The radio signal's quite weak. If the animal goes behind rocks, the signal is blocked. And you only get information while the researchers are around to collect it. Martin has started to use a new invention, a device which measures heart rate and body temperature once a minute, and stores it on a microchip sealed within the implant. The whole device is sealed in a waterproof resin and inserted under the skin of the anesthetized animal. It will stay there for several weeks. After a few days to recover from the operation, the iguana is released and the data collection starts. Later, it will be recaptured and the device recovered. Then the information can be analyzed.
You can see that even though the temperature drops down in the night, there are some changes, and this is probably because the animal moved its position inside the rocks. And you see a really smooth warm-up curve. So we can calculate a mathematical function about this on this warm-up curve. And there's no inaccuracies in the data because people didn't count right or take the time wrong. And you also see that during the foraging period, there's a really nice drop and then afterwards an increase in the body temperature again. Then also the nice drop in body temperature in the evening or in the afternoon, and a little bit of increase again when the animal moved from its rock to a rock that was slightly further in the sun. So that's what they do around 4 o'clock or so in the afternoon. So all this can be nicely picked up and interpreted into this file if we combine it with our behavioral observations.
Among other things, science is about taking your chances when you find them. Martin's always been interested in the diving physiology of the iguana. If he understands how the heart operates, he's got a clue about the efficiency of blood flow.
Clearer.
Quite by chance, he finds out about Beatrix's ultrasound work on the main island. He jumps at this opportunity to look at the dynamics of a heart operating.
So this, you can see the heart pumping here, and now we can make it like a little bit bigger. You see the movement, and here
Oh yeah, that's pretty
it's the largest one, yeah. And here it's ending, and here too. If you move with the ultrasound, with the head of the ultrasound a little bit, and you can see how the blood is going through, the rhythm of the heart here.
What we've seen here is just a snapshot of research taking place.
And it's also a very huge one. They have 2 very huge eggs. I think this is normal, 2 eggs, or?
Yeah.
Yeah.
They already have some of the answers, but it's a long continuing process, slowly assembling very simple pieces of information, informing our understanding of a complex natural world. And perhaps more importantly, allowing them to conserve and manage this fragile fragment of our planet.
If you'd like more information about the Earth and Life series, call us on 0541 596 955 or write to the Open University, PO Box 625, Milton Keynes, MK7 6AA. We also have a website and a CFAX page.